And all right, thanks so much. And take it away, Chelsea. I think you're muted. Let me see if I can fix that for you. Unmute.
I'm unmuted now?
Yes.
Excellent. Okay, now I need to figure out how to share my screen. Usually there's buttons along the bottom, right?
Yeah, it may have put you in full screen. Sometimes it does that, and it can be confusing when that happens.
Interesting. I'm not in full screen, but I'm also not seeing the option to,
Is there a menu bar at the top?
There is. It says meeting start share.
There you go.
I can share. Oh, I see. Okay, wait. I think I figured it out. Everyone, you're seeing the very first iteration of this online meetup and everything that comes with that. So when this thing is a raging success and hundreds of people are coming every time, you can say you were at the first one and you saw us figuring out how to use the technology. Okay, can everybody see my slides? Let's see here.
Yes, and I'll be monitoring the chat.
Much appreciated.
Do you want me to mention questions during, or do you want me to mention questions after?
Let's do questions after. Does that sound good?
That sounds great.
Awesome. Okay, we're going to do questions after. So hi everybody, welcome. My name is Chelsea Troy. My pronouns are she and her. They, them is also fine. I am a software engineer and a data scientist here in Chicago. I worked at Pivotal Labs for about 3 years, and then after that, I moved to a company called Ascent Technologies. I was responsible for some machine learning models there. And then this summer, I'm going to be joining the Zooniverse, which is a project sponsored by the Adler Planetarium here in Chicago, and it supports citizen science projects, which you will hear a lot more about from me if you follow me on Twitter, any of those things. But today, we're not going to talk about that. Today, we're going to talk about refactoring and the strategy behind refactoring code. All right, so let me see if I can present this. All right. My hope is that I can provide something for everyone today. So we're going to cover some technical level details for the software engineers in the crowd, and we're also going to cover some operational details for product managers and designers. All right. Here we go. So what is refactoring? Can people just mention in the comments who's done a refactor before? Has everyone done a refactor? Raise your hand if you've done a refactor before. Okay, cool. All right, how many of you love refactoring? Love it. Okay, how many? Okay, awesome. A lot of people. How many of you hate refactoring? A couple. It's a love-hate relationship, maybe both. So if we've done it and we have opinions on it, we definitely know what it is, right? Or maybe it's kind of one of those I know it when I see it things with refactoring. So we have sort of a canonical definition of refactoring. The canonical definition says it's something like this. It says it's changing the design of existing code without changing the user-facing features. So you'll hear this frequently. I don't love this definition. And the reason I don't love this definition is that it comes with two assumptions baked into it. Specifically baked into this term, user-facing features. So the first assumption in this term is who is a user. Refactoring changes the developer-facing characteristics of a code base. And I would argue that developers are users. Now, before the designers in the crowd get on to me, here's what I mean by that. So it's true that in many cases, code design is, and it should be, secondary to the software's functionality. So if the only way to write the feature that end users need is with messy code, or the only way to do it right now is with messy code, then we need to write the feature that way, and that's life. Because if the software doesn't work for the end user, it doesn't matter how beautiful the code is. But it's also true that if the code is illegible, the software will very quickly not work for the end user because developers will have a hard time understanding it and they'll be afraid to touch it. So updates will take too long, or they may even become impossible. No designer wants to hear that a small tweak to the animation is going to take 2 weeks, right? So we keep code in a maintainable state to minimize that kind of wait time for everyone, designers, developers, end users, everyone. Okay? There's another assumption baked into the term user-facing features. What is a feature? So we tend to equate user-facing features to content and navigation features, buttons, tabs, text, pictures, requests, that kind of thing. And sometimes we call these features functionality. That's certainly one kind of feature, but it represents a very small sliver of the totality of features that we may want to write. Other kinds of features include scaling. Does the software work when a lot of users are on it? Does the app work when the network connection is heavily taxed or poor or non-existent? We'll talk about a couple of cases of this later. Another kind of feature is robustness. Does the software respond gracefully to unexpected input from the user or a network call that returns a response that we're not expecting? Or what about security? Does the software keep users and data safe when hackers try to compromise it? This is a feature that Equifax didn't have at a time that it was very important that they did, right? Or how about accessibility? Does the software work for users who use screen readers, large font, high contrast UIs, loud and clear sounds? Does it work for users who have compromised motor control or dexterity? This is really important in mobile apps and tablet apps that require a touch screen to interact with. Or how about inclusion? What do we mean by inclusion? Does your computer vision app work for people with dark skin? Does your software only ask questions about user sex and gender if it absolutely must? And if it must, does it ask those things in the right way? Does it work for all different body shapes and sizes if it has anything to do with the body at all? All of these are features, just like profile pages, just like buttons, just like news feeds. And we often refactor precisely to get some of these features, right? Better error handling, for example, or better network performance, or better predictive results. But whether we call that a new feature or a refactor isn't clear. By labeling our work as a feature or as refactoring, based on whether users notice a difference, make some assumptions about who is a user, and we don't have to make those assumptions. Instead, let's imagine that software exists on a continuum toward maintainability, and refactoring is the work that we do to make our code as maintainable as possible. So, what does it mean for software to be maintainable? Well, we're looking for 3 things specifically, and I'd like you to think of them as constant works in progress on a software product. Refactoring is the thing we do to give our software more of these qualities. First, we want software to be collaboration friendly. We want to ask the question of ourselves, how can other technologists maintain this code together? This is the thing we most commonly associate with the term refactoring because we want to leave the code clean and organized so that other developers can figure out what it does and maybe even why. So who does this well? Well, I have a few examples for you. One of them is the Spring Framework. The Spring Framework, it's a web framework for Java. It makes exemplary use of documentation, rigorous tests, thoughtful syntax, to keep code legible and thoroughly explained so that their distributed team and outside contributors can understand and improve the way it works. Spring, I've heard it referred to as the Rails of Java, kind of. You can think of it as a web framework for Java with interchangeable modules that allow you to do different things in it. It's an open source project. The people who write this write together from all over the world, and they also have outside contributors contributing to it. Very, very, very important that multiple people be able to collaborate on it in different time zones and with different cultural norms. So it's a great example. Another example is the Apple Swift programming language. So this programming language is a compiled, typed language. Apple, I believe this was published in 2014 and then open sourced a little bit later, also in 2014. So you can go and look at the source code of Swift on GitHub. Swift leans heavily on optionals, and it includes a lot of features to ensure the safety and the legibility of the code written in it. And in that code, you can see their commitment to concise and legible definitions of things, which I think is really impressive. When code isn't collaborable the way that Swift or that Spring are, we end up with the opposite. We may end up with, for example, an arcane legacy system that developers are afraid to touch because they're afraid to break anything. And if the situation gets dire enough, the company may commission a complete rewrite rather than maintaining the existing system. So we want software to be collaboration friendly. We also want it to be dialogue friendly. By this I mean, how does a user or a developer share their expectations about this program? The feedback cycle is an important part of software development. So if we want to develop maintainable software, the software has to merit maintaining by being used. Somebody has to use it. And in order for software to be used, we need to make sure that it keeps up with what users and development teams expect it to do. So how do we do that? Well, when we deploy apps, maybe we do user testing, right? Or sometimes we use App Store ratings to get information about how our product is doing. Google's products often provide mechanisms for users to show how their expectations differed from what they got. So I found this example that you see on screen now. These dialogues appeared while I was looking up how to do something in Gmail. And I can choose whether I found this article helpful here in the first picture. And then if I didn't, if I click the no button, then Google shows me a text field to explain what I needed, which you see in the second image. Software that fails to open this dialogue runs the risk of getting out of touch with user needs and becoming shelfware. So we want software that gets used. It's important that it be that there be a dialogue. The third aspect of maintainability is resilience. By this, I mean, how does the code react to unexpected or unideal inputs? A resilient app anticipates the things that a user could do, and it reacts gracefully even when something happens that it didn't anticipate. When software isn't resilient, we end up with failures where the software is clearly not working as intended or where the development team didn't anticipate something that could happen. You know what, I'll give you an example. I once worked on an app for ramp agents. This is a ramp agent. They work on the tarmac at airports and they scan luggage, pets, mail, military equipment, and hazardous materials into the hold of commercial airplanes. Fun fact, you may not have known this, 80% of the profits that some airlines make off of their commercial flights have nothing to do with passengers and everything to do with carrying mail for the US Postal Service, which in some cases may explain the level of concern that they have about angry passengers. Anyway, for these ramp agents, we built this beautiful app to help them scan all of the mail, all of the hazmat, all of the bags into the plane. The API client for this app made calls to a server in real time to scan each bag, and they return updated information about the whole flight. It was calculated on the server with every call. So we sent it to the tarmac for user testing, and the product owner came back to report that ramp agents spent 10% of their time with our app scanning things. So what were they doing the other 90% of the time? Believe it or not, they were walking around on the tarmac, which, by the way, is where the planes go, holding the phones up in the air. Why do you think they were doing that? The reason they were doing this was that it was the most likely way to get a network signal, and a network response blocked every single scan. That wasn't going to work, right? So we completely refactored the app. This time we had a question in mind, which essentially was, how much stuff can we do without any network connection at all? We couldn't coordinate scanning between scanners this way, so we assigned each scanner to a pit in the hold, which is like a compartment in the hold of an airplane. There's 6 of them generally on your large commercial planes. And we would queue the scanning requests for each pit in the hold. At the very end of scanning, the ramp agents needed a network connection to connect to check some security things. You have to check a couple of rules about what can go on an international flight and make sure the weight is balanced throughout the hold of the plane. So they could guarantee the network connection that they needed by plugging the phone into a networked holder called a cradle, but just once at the end of scanning rather than in between each scan. So we took an existing app that did not do at all what the users needed, and we worked together to translate that feedback into changes that worked. Now, this is an extreme example that I chose for clarity, but this happens on a lot of software. Requirements change out from under you. We write maintainable software precisely so that when the underlying requirements change, our code is ready to change too. Because writing maintainable software means assuming that our assumptions will be wrong. Software has to change when it was originally written under assumptions that are not true, or assumptions that are no longer true. So how do we hedge against the possibility that our assumptions are wrong? We can do that by noticing and examining our assumptions. As I was developing this talk, Kenneth Mayer asked on Twitter, when is enough refactoring enough? And I think it will be helpful to approach this question with an example. How many of you have heard of dry software engineering? Show of hands. Okay, a few. What does dry stand for? It stands for don't repeat yourself, right? This is an adage that developers learn to avoid duplicating stuff in code. Coraline Emke, a developer here in Chicago, articulates a misunderstanding with this term. She explains that the point of dry is to not repeat concepts. It's not referring to individual lines of code necessarily. Sometimes it makes sense, for example, to leave similar lines of code in several places, because when you extract a variable or a class or a method for them, you communicate the perspective that these two things are the same. And sometimes they're not. Suppose, for example, we have a class representing each view in our app. You'll see this example here on screen. This is Java. We have a list view and we have a detail view. So we have one screen on our app that shows a list of stuff, and then when you click on each one, you go and you see details about it. So in each one, we need to load the view, handle button taps, and load up a navigation bar on screen. So you see these methods here to handle those cases. They both our views do all of these things, so it makes sense to extract a superclass. Let's call it view. See that? So now we have our view class and our list view and detail view extended. Great. Now we want to add a login screen to our app. So we make a login view, and we still need to load the view, handle button presses, etc. But no navigation bar here since there's nothing to navigate to until the person logs in. What do? Do we subclass view and then no op the load navigation bar method to turn off that functionality? Do we maybe pull loading the navigation bar out of the superclass and add it back to the subclasses that used it? So now we've added that method back to list view and detail view. We've taken it out of our general view. Or maybe this is a case where creating a collaborator could be a helpful design pattern. So now we have our navigator, that calls it, that we can include in our list view and our detail view. Or maybe we can do it by creating a taller hierarchy. So now we have our view, and then we have a navigation view that extends view, and then we have list view that extends navigation view. So now view is the grandparent. Well, same thing for detail view, but login view extends view directly. A side note here, you'll see very tall hierarchies like this in mobile frameworks precisely because in a mobile framework, a lot of stuff has to get handled under the hood for the purpose of reference counting and making sure that everything fits in the small memory footprint that you have for a mobile phone. So you'll see tall hierarchies like this in a lot of Android and iOS apps. But if you need default functionality rather than interface adherence, and you're working with a language that prohibits multiple inheritance or something, that kind of pattern may not be an option for you. So instead, we get a new rule, the rule of 3. What's the rule of 3? It's the rule that code should be duplicated in at least 3 places before factoring it out. Why? What is it about 3? 3 is not a magic number, right? We could factor out the navigation bar, get 8 views in, and then run into the exceptional class and have to decide between subclass and no op or adding the nav bar method to the other 8 classes. 3 isn't a magic number. 3 is instead a rule of thumb, because if we have to do something exactly the same way 3 times, the probability is higher that these things really are the same than if we only have similar functionality twice. So how do we judge when to start refactoring or when to stop refactoring? Feel like this? I drew this seesaw myself with shapes. We have refactored enough when we have balanced the probability that this will change times the amount of work to make that change. That's what you see on the left of the seesaw. Against the amount of work that we're willing or happy to do. And that's what you see over here on the right of the seesaw. In finance, when we multiply the probability of something happening and the cost of, if it does happen, we call that the expected cost. So this is a similar concept. In this case, we're balancing the expected cost of maintaining this software with the cost that we'd be happy or at least willing to bear. And in order to make that calculation, we need to ask some questions as we plan how to write our maintainable code, right? So here's the first one. It has to do with the probability that this will change. How likely is it that we'll have to change this? It's really tough to get a definitive number here, but we can use a few cues to get an idea. For example, the more examples we have in code that support our assumptions, the more likely it is that those assumptions are still useful, and the less likely it is that we'll have to overhaul this code later. This is the generalized version of the rule of 3 that we talked about before, right? More examples, more likely to be what we expect. Or more customers. So the more customers we have using our app in a way that we thought they would use it, the more likely it is that our understanding of their needs is accurate, and the less likely it is that we'll have to overhaul the software later. Regular feedback cycles allow us to catch and correct differences in user expectations too. So it's less likely that we'll have to make sweeping changes later on. By asking, how likely is it that we'll have to change this, we can estimate the probability part of our expected cost of maintenance. But there's another figure in there, right? We still need to estimate the amount of work part of our expected cost. So that's our next question. How much work is this to change? Again, it's tough to get a definitive number, but we can take some things into account as we make a guess. For example, consolidating is usually less work than separating. I mean, it's less work to consolidate our views to inherit from a superclass with duplicate functionality than it is to break apart the superclass again when we realize it represents a concept that's too general for our use case. So this is an argument for drawing things up maybe a little bit later than we sometimes do. It's also usually less work to change documented patterns than undocumented patterns. This is important when we're deciding whether to go with system patterns or conventional patterns, or your own bespoke ideas for writing software. The more commonplace the pattern you choose, the more Googleable it'll be if team members run into issues with it, say if you're not available to answer questions or if a large team needs to work on it. It's also usually less work to change an existing system than to start over, right? Refactoring the scanning app that we talked about earlier for the ramp agents, it was a monumental project. It was huge. And as monumental a project as it was, it still involved less work than rewriting that app would have been. Even sweeping refactors can save the team down the line from needing to do a complete rewrite. By the same token, replacing the plumbing in a building may be an expensive and onerous task, but it's still ripping down the building and starting over, right? That's why it's worthwhile for teams to make these sweeping refactors, and it is worthwhile for technologists like us to build our skills in making these sweeping refactors. So let's talk about planning and selling refactors. We've talked about the technology of refactoring so far. Now we're going to start to switch into the psychology of refactoring, because we know now even a big sweeping refactor may be worthwhile when we put it next to rewriting the whole thing later. So we know that, right? However, in many cases, sweeping refactors still require some negotiation because understandably, stakeholders, they don't love to hear that we need to sink a bunch of developer time into a major change that won't result in more navigation or content features. To them, that sounds like a lot of risk for no upside, right? So it makes sense that they don't love it. As I was developing this talk, Brent Halliburton asked on Twitter, let me pull it up. Here we go. As a product manager, what can I do to help my engineering team be successful in appropriate refactoring over the life of a code base? So here's the information that a product manager can collect to make space for development teams to refactor. First of all, what future developments does this change affect? And how does it affect them? People respond. to the prospect of losing something. So the product manager can figure out what perceived pain or loss does this change address. Maybe refactoring an inefficient server pattern will allow your company to save $8,000 of the $10,000 it's currently spending per month on AWS costs. That makes the refactor a lot more attractive to a stakeholder. Or maybe this refactor allows multiple engineers to more easily work in the same part of the app, so work streams don't get blocked and execs aren't paying developers to sit around waiting in line to deliver code. That can also make a refactor more attractive to a stakeholder. Finding the pain or the loss like that will help product managers make a case for a sweeping refactor being mission critical. The tech team might know something about that pain or loss, so you could ask them, or the sales team might know something, so you can ask them too. Product owners and potential customers can also help uproot these worries that these changes can address. So that's a potential source of motivation for selling. Here's another one. How can we maximize value delivery over the life of making this change? If we have to make a sweeping change, how can we incrementally perform this change to produce benefits from the very beginning so the business doesn't have to wait on results? Suppose, for example, you have a server that clients can query for the contents of federal laws. That's a lot of text. So the responses take a long time to serialize and deliver over HTTP. Also, no human can effectively interpret that much text at once. It's like 90,000 words on the short end. So you're working on a filtering feature so that this endpoint will now only serve the most relevant pieces of text for what the user is looking for. And this is important. You never want the call to take as long as it currently does. So this is the refactor you're doing. How do you deliver user value before the new filtering feature is done? Maybe it's going to take a while. So you could maybe set up a temporary endpoint that delivers the most read pieces of text and redirect to that while you finish the filtering. Or maybe you can pre-populate some suggested search terms and make an interim version of the filter that only serves up results for those terms. It's valuable to think creatively about the question, how do I deliver the most value to the user with the smallest amount of work? The best tech teams can leverage this question to sneak monumental undertakings piece by piece through the pipeline, delivering value the whole way. I think that this technique of figuring out how to deliver value upfront and procrastinate the more time-consuming changes has been more valuable to me as I've advanced in seniority than any individual contributor, any finesse as an individual contributor that I have. Let's talk about allies for a second. Because even with the best sales strategy, sometimes your team might need a little help to get buy-in on a sweeping refactor. Who can you turn to for help? You have a few options that are often overlooked, so I'd like to highlight them. Here we go. So first one, the sponsor of the project. This is not necessarily your end user. So for example, if you're writing an app for a health insurance company's enrollees, the enrollees are not the end user. Or they are the end user, but that's not who creates demand for the app. Your end users are the enrollees, but the demand comes from the insurance company's clients, employers who offer this insurance to their staff. If you can convince those sponsors and the people who speak for them that this refactor is important, you can open doors that might otherwise be closed. So that's the first one, the sponsor. Second of all, the peanut gallery. Show of hands, who's heard this term peanut gallery? A few? So I got some fun trivia for you. The peanut gallery is a term with its origins in French vaudeville performances, and it refers to the topmost gallery of a theater where the cheapest seats were located. people would sit there and they would eat peanuts. That was like the snack up there. And they would sometimes throw them at the stage. So in modern parlance, the peanut gallery is slang for all the people who are like removed from the action, but nonetheless feel the need to lob their comments around, which usually are not that useful. That's where this term comes from. So it can be really annoying when stakeholders have conflicting views of what should go into the software, right? But conveniently, if your refactor furthers several of these stakeholders' goals at once, your refactor might skyrocket to the front of the priority list by virtue of being the only thing multiple stakeholders agree on. So it's a good trick to keep in your back pocket. So that's another set of allies you could have. Third ally you might have: the person who wrote it the first time. If you're refactoring something, that means it was originally written some other way. It can be tempting in that situation to denigrate the original choices and even the people who made them. I recommend doing the opposite. The people who wrote it the first way might have intimate knowledge of the technical or institutional limitations that forced that original design. And they're also the ones with the most practical perspective from which to advise on how they would do this feature if they had it to do again, just like you were doing. I recommend valuing this person's work and seeking their counsel. I'll give you an example. I once worked on a rewrite that would have gotten completely blocked on some idiosyncratic API details that were known only to the person who wrote the thing that we were rewriting. Without his help, the rewrite would have absolutely failed. We ended up naming a whole menu in the rewritten application in his honor when we finally got it written. So to wrap up, let's wrap this up. What have we talked about? Well, we've talked a lot about refactoring, right? We generally think of refactoring as improving the design of existing code without changing user-facing features, and that's a hard line to draw. I actually don't think that we have to draw it, right? Instead, we can focus on making our code more maintainable, more collaboration-friendly, more dialogue-friendly, and more resilient. We can do that by making an effort to notice and examine our assumptions and to consider the probability and the cost of our assumptions being wrong later on. This puts us in a good position to adapt our software to change. And change, even big change, is often more practical than rewriting software from scratch. But how do we sell the business on big changes, especially if they don't come with obvious changes to the software's functionality? Well, then we need to practice the psychology of refactoring. We can identify the pain that our refactors address and sell our ideas that way. Then we can plan our work so that we deliver incremental value the whole way through. And when it comes to it, we can also reach out for help, remembering that sometimes that help might come from some unlikely places. If you're interested in diving deeper on the topic of refactoring, I'd also like to recommend some additional resources that I tend to turn to. The first one is Christine Gorman's talk, How to Make Your Code Sustainable. I believe she gave this at Java Zone a while back, and it's available online now for free. It's a great video. I refer to it all the time. There's also a great book, Working Effectively with Legacy Code. This is by Michael Feathers. The examples in the book are written in Java. However, I have used examples from this book on Java projects as well as .NET projects, Swift projects, Golang projects, Ruby projects, an Objective-C project, and Python projects. It really spans the gamut in terms of the patterns that it presents, and I found it useful in working in all kinds of frameworks. I have 2 copies of this book. I have one at work. I have one at my home. It's fantastic. And then finally, We Cohere delivers a workshop called Real World Refactoring. It's about 2 hours. They take you through a practical example where they start with some code that could use some refactoring, and you collaboratively make some choices about how to refactor it. They tend to do it in small groups, and they can do it in person, or they can also do it remotely, and they're happy to do it with teams of people too. So you could have your whole development team inside of this workshop with them. With that, I can give the rest of my time to questions.
Thank you so much, Chelsea. And I think right now everyone's muted, and it'll probably help us kind of like queue up the questions if people can put them in the chat. I'm really interested in what people have learned from this talk, or if you had a favorite slide. Please comment below in the chat. I know that I love the refactoring seesaw. So I'm just going to give folks like a minute to figure out what they want to ask about. And let's see. And also, those are some great resources, and we can work together to just sort of include links to that stuff in the wrap-up email that I send out after this.
Yeah, absolutely. I'll also go ahead and mention that I do have a full transcript of this talk. It might not be exactly what I said to you tonight, but it's pretty similar, and it has a lot of that stuff linked up. It's on my blog, so I can send a link to that for folks if that would be helpful.
Sure, sure. And then we will be posting this this video up on the PearConf channel.